Welcome to the deep dive. Today, we're plunging into a topic that's, well, maybe a bit overlooked when we talk about the future of AI. Everyone's focused on the latest models, these mind-blowing applications, right? But what if the biggest challenge, the sort of hidden crisis, is actually just keeping the lights on? So our mission for this deep dive is to unpack a critical set of sources that they reveal AI is really on a collision course with our global energy infrastructure. You'll learn not just about the huge power demands of AI, but also some surprising real-world consequences. And importantly, where the true opportunities might lie if you look beyond the hype.
Yeah, and what's really insightful from these sources is how history seems to be, well, repeating itself, but maybe with a unique twist for AI this time. Our analysis highlights this pattern where new techs, think direct-to-consumer brands or even social media platforms, they eventually start existing mainly just to sustain themselves. And AI, it turns out, is falling into this very pattern really fast, threatening to, as one source puts it, eat the electrical grid alive in a way we haven't quite seen before.
Okay, let's put some numbers behind this, because the figures in the sources we looked at are genuinely staggering. Can you help us visualize that? Like, what kind of scale are we actually talking about here?
The scale is, it's hard to wrap your head around, honestly, even for people familiar with energy use. So training GPT-4, just as one example, consumed 1,750 megawatt hours of electricity. To give you a concrete idea, that's enough power for about 160 average American homes
Wow.
for an entire year. And, the demand is only going to accelerate from here.
And what's particularly striking, I thought, from our sources, is the projection that by 2030, which isn't that far away, AI could be eating up 3, maybe 4% of global electricity. I mean, just to put that in perspective for you, that's more than France uses today.
Right. And a crucial point that comes out of the analysis is the sheer speed of this unfolding crisis. It's a speed. You can build these data centers, the physical homes for AI, relatively quickly, maybe 1 or 2 years. But the grid upgrades, the heavy lifting needed to actually power them,
Yeah.
those take maybe 8 to 10 years. It's a huge difference.
8 to 10 years. Wow.
Yeah. And this mismatch, this time lag, is already causing real, tangible consequences for communities and potentially for you.
So what does that look like on the ground? What are these real-world implications? Our sources give some pretty stark examples. Pennsylvania actually threatened to leave the PJM grid operator. That's a huge operator covering 13 states in the U.S.
Where are the base?
because power prices were soaring. And in Dublin, it was even more dramatic. They just banned new data centers entirely
Completely banned them.
because they were sucking up nearly a third of all of Ireland's electricity.
A third, yeah.
It's incredible.
And even Norway blocked a factory expansion specifically to prioritize power for, you guessed it, data centers. It's not theory, it's happening right now.
And you might also be surprised to hear that the U.S.'s largest grid operator, they're anticipating something like 32 gigawatts of new data center demand by 2030.
32 gigawatts. Gigawatts. Yet, at the same time, we have gigawatts of renewable energy just stuck in approval queues. They can't get connected. This investment lag, this gap, it's so significant that tech companies, big ones, in places like Virginia and Texas, have already had to delay data center projects.
Just so they couldn't get the power.
Exactly. Simply due to power constraints. It's a massive bottleneck forming.
Right, and it's clear this isn't just about keeping the AI servers humming. Our sources paint a much broader picture. This existing infrastructure, built for a totally different era, it's showing signs of strain, breaking down globally. We're talking massive blackouts, not just flickers, like Texas in 2021, Pakistan in 2023, Spain just this year in 2024. These aren't just random failures, are they? They seem like symptoms.
They really are symptoms. Symptoms of a system under just immense, unprecedented stress. And if we step back, look at the bigger trend, this energy crunch is actually starting to impact global climate commitments, which is concerning. The demand for power is just so intense that some nations are making surprising reversals on green policies. Our sources mentioned Vietnam slashing $13 billion in wind and solar subsidies.
13 billion, ouch.
Yeah. Australia abandoning green hydrogen projects. The UK delaying its ban on petrol cars. These aren't small shifts.
And what's truly astonishing, I found, is Germany actually bringing coal plants back online.
Coal, yeah.
And the U.S. cutting billions in climate funding, while at the same time deferring 400 gigawatts of clean energy capacity that's ready to go.
400 gigawatts just waiting.
India, too, has relaxed emission standards, exempted, 79% of its coal plants from installing pollution controls?
That's right, nearly 80%.
It really drives home the pressure, doesn't it?
Absolutely. And the clear message from the sources we look at is that These aren't just, political decisions or policy whims changing. These are often direct consequences of having an outdated electrical infrastructure that just cannot keep pace. The choice countries are facing is often between, well, economic progress, digital advancement, and environmental goals,
Yeah.
because the power isn't there to easily support all three at once.
Okay, so faced with this crisis, the big tech companies aren't just sitting around, right? Our sources show they're actively building their own solutions, kind of taking matters into their own hands. Like Microsoft investing in nuclear power, trying to resurrect parts of Three Mile Island specifically for data centers,
Mm-hmm.
or pioneering Project Natick, those underwater data centers, which are apparently cooler, greener, and way more reliable than the ones on land. 8 times, the sources said.
8 times more reliable, yeah. It's fascinating innovation driven by necessity. And another intriguing finding from these reports is Meta also looking seriously at nuclear energy, specifically small modular reactors, SMRs.
Right, the smaller ones.
Exactly. And China is experimenting with wind-powered undersea data hugs too, trying to cut electricity use by maybe 30%. So these tech giants, they're creating these bespoke, custom energy solutions because they simply can't rely on the existing grid infrastructure, not for the scale and the reliability they need.
But here's a really fascinating twist that our sources brought up. It suggests that AI's first big job might actually be saving itself. The technology is turning inward, applying its own capabilities to solve its own massive power problem.
Yeah, which naturally makes you ask, okay, how? How exactly does AI help itself? And the material we reviewed outlines several key ways. It's being used for predictive grid maintenance, so anticipating failures before they happen.
Smart.
Developing self-healing networks that can automatically reroute power if there's an issue. Crucial load forecasting, predicting energy demand much more accurately. And it's even optimizing its own energy use inside the data centers, using things called virtual power plants, which sort of balance energy consumption across different facilities intelligently. This recursive pattern, technology solving the problems it creates, it does offer some hope for breaking this cycle that has kind of trapped previous big innovations.
So thinking about all this, for someone trying to figure out the future of tech or maybe just understand where the smart money is heading, what does this infrastructure crunch really mean in terms of opportunity? Our sources have a pretty clear insight here. While everyone's chasing the next flashy AI model company, the real opportunity, the potentially more stable long-term play, might be in the infrastructure that supports it all.
Exactly. And one intriguing finding from these reports is just that. The spotlight is often on the AI models,
Yep.
the brains,
Yes.
right? But the genuine long-term opportunity could very well lie in the underlying infrastructure, the backbone. These aren't the glamorous investments, definitely not, but they are absolutely essential. Our sources call them the picks and shovels of the AI revolution, things with, long-term pricing power and pretty stable demand.
And the smart money, based on what we read, seems to be moving towards companies building advanced grid hardware. Things like smart transformers that can manage power flow better, dynamic transmission technology, allowing the grid to adapt faster.
More responsive.
Grid-scale battery manufacturers, storage system providers, they're seeing unprecedented demand. Even, interestingly, recycling companies, the ones keeping critical materials like copper and cobalt flowing, suddenly they're recognized as vital infrastructure too.
And this also brings us to think about, well, what about the AI chips themselves? Our sources point to engineers designing more energy-efficient AI chips as another really crucial investment category, cutting demand at the source. So the bottom line, the research suggests, is that often the most quote-unquote boring investments turn out to be the most profitable in the long run.
Okay, so we've talked about the problem, the immediate power crunch, and some of the solutions emerging, both from tech companies and AI itself. But if we zoom out again to the global stage, our sources uncover this kind of uneasy geopolitical standoff developing. And it could shape AI's future maybe more than any single algorithm breakthrough.
Yeah, that geopolitical dimension is a truly compelling aspect of this analysis. You see this stark contrast in energy strategies. So while the U.S. generally leads in, let's say, AI innovation and chip design, the brains,
Right.
our sources highlight that China has two, well, quiet but pretty significant advantages on the backbone side. First, it generates over twice as much electricity as America. And second, it's expanding its capacity much, much faster.
And our sources also point to China's centralized control over critical minerals needed for things like batteries and grid components. Plus, its big push for chip self-sufficiency, which, stands in pretty stark contrast to America's dependency on foreign suppliers for some crucial components, transformers, certain minerals, other key grid elements, does highlight potential vulnerability there.
So the critical choice AI now faces, as framed by these sources, is whether it can build the really robust foundational energy system it needs. Or does it risk becoming another one of those cautionary tales? Innovation trapped by its own success because the infrastructure couldn't keep up. History shows technology consistently outruns infrastructure. Think about rural electrification taking decades, or the environmental costs of the industrial age that we're still dealing with. Even the recent renewable energy rollout, we saw gigawatts of clean power basically stranded because there wasn't enough transmission capacity.
Right, couldn't get it to where it was needed.
Exactly. So this brains versus backbone contest, as our sources put it, is now playing out on a global scale for AI.
So what does this all mean for you listening to this?
Well, the future of the AI revolution, according to our deep dive into these sources, it seems to depend less on the next flashy breakthrough model, and maybe a whole lot more on those humble but absolutely vital infrastructure investments.
Yeah, what's really insightful here, I think, is that the companies quietly building the electrical backbones, the massive storage systems, designing the efficient hardware, they are the ones that might be likely to outperform the more hyped up AI stocks over the long haul, which raises, I think, an important question for you to consider. Who ultimately is going to keep the lights on for this AI revolution, and how might that sheer necessity shape everything that comes next?
Something to chew on, right? We hope this deep dive has given you maybe a fresh perspective on a problem that is quite literally powering our future, or potentially failing to. Thanks for joining us.